Okay, so this one's probably a little bit trickier again because we've got a perfect square and a bit more. So let's start with the same principles that we did before. Let's find our y-intercept. So our y-intercept, let's find our x-intercept, which is I was wrong. Let's start with our y-intercept, when x equals 0. That's where we started all the others. This is where we'll start this one. So again, we'll say y equals, substitute in the 0 for the x, and then we'll solve it. 0 plus 3 is 3, 3 squared is 9, minus 5 is 4. So that tells us that our y-intercept, so when it crosses the y-axis, is when x is 0 and y is 4. So we'll mark that point off. 1, 2, 3, 4. So that's our y-intercept. So let's do our x-intercept. And that is when y equals 0. So this is our null factor law. So 0 equals x plus 3 squared minus 5. Now, we know that when we're doing a difference of two squares, that this must be negative. Difference of perfect squares. If that's a positive, it doesn't actually cross the x-axis. Okay, it doesn't go below the x-axis. But in this case, we know that it is because that's a minus. So we can use difference of perfect squares to work out this. So we're going to have two sets of brackets with x plus 3, and we're going to have minus 5 in this bracket, minus the square root of 5 in this bracket. Remember, we find the square root of this term and the square root of this term, and we put them in our brackets, and one's going to be positive and one's going to be negative. Okay, so just for sake of ease, the square root of 5 is 2.24. This is just for this example. I'm writing that in just to make it easier to follow. So now we work out what x is equal to in both of these, because we're going to have two values, which will be the two places that it crosses the x-axis. So 0 equals x plus 3 minus, I'm going to use the number here, 2.24, or 0 equals x plus 3 plus 2.24. You would normally use the square root, but for this example, I'm just going to find a value and round it off. So to get x on its own, we have to subtract all of this from both sides. So we're going to have x equals minus 3 plus 2.24. And to solve this, minus 3 plus 2.24 is going to be 0.76. So that will give me the point when y is 0, so it's 0.760. That's on one side, so that's going to be approximately here. And then on the other side, I'm going to have x equals minus 3 minus 2.24, which is going to be equal to minus 5.24. And I'll do that one in red. So that's going to be minus 5.240. So now we've got 1, 2, 3, 4, 5. So that's about here. So now we've got a graph that's going to come somewhat like that. Now, the turning point in this one is actually quite easy, because these these here basically give us our turning point. So I'll just write this equation, y equals x plus 3 squared minus 5. Our equation for, a general equation would be y equals x plus h squared minus k. And in this occasion, our turning point is actually minus h, actually that should be plus, minus h k. So if you take this rule, and you apply it to this equation, minus h is minus 3 and k is minus 5. So this is our turning point. Minus 3, minus 5. 1, 2, 3. Sorry. 1, 2, 3. 1, 2, 3, 4, 5. So that's our turning point. Minus 3, minus 5. And that's our parabola. Alright, so that's another way, that's our third exercise in graphing parabolas. Just one more to come.